Alright, so this video is about writing an equation for a quadratic in factor form using this graph. And just for the record, factored form basically means the form y equals a x subtract p and then x subtract q. That'd be factored form. Standard form is slightly different. Standard form is y equals ax squared plus bx plus c. We're going to write in that form too, but this video is mostly about writing in factored form, where you need to find the x-intercepts and the a value. Sometimes factored form is called intercept form. So factored form and intercept form are the same thing. Factored form or intercept form. Intercept form mean the same thing because they both are helping you find the factors. So looking at this graph, I want to do that. I need to find the a value and the p and the q values. P and q are the intercepts. So this is the intercept and that's the intercept. So this would be p, and this would be q. So that's true. The first x value here is -1. Instead of writing p, I'm just calling x equals -1. And other x value is 3. So x equals to 3. So given those 2 points, and also I need a. So I need p, q, and a. If you want to find the a value, you go over 1 unit to the right, and then go up and touch the graph. In this case, the a value is 1. So no, a is 1. So that equation in the form y equals to a, get this out of the way for the moment, y equals a, and then x subtract p, x subtract q. It's going to be y equals 1, then x subtract -1 means x plus 1, and then x subtract 3. So that is the intercept form or factored form. We'll talk about writing in standard form next, but that's the factored form. I'm going to my next one. Looking here, I first want to find p and q. I'm not always writing in p and q because a lot of times I don't even think about it as p and q. I just think about them being the x-intercepts. So the x-intercepts are x equals to +1 and x equals to 5. So, and I want to always write x equals, I might just say 1 and 5. X equals 1 and 5. The a value is also 1 in this case. So when I go over 1 unit, I went up 1 space. So a is 1 in this problem as well, because the distance I went up to touch the graph. So right into that form, y equals to a, x subtract p, x subtract q. It's going to be y equals to 1, and then x subtract 1, x subtract 5. And now I have it in the in the factored form and in the intercept form. In this case, in this graph, you really can't see the a value. So using just p and q, so x would be negative, this is 2, 3, 4, so -4, and x would be 2. So the a value, they didn't really tell me. Can't really see where it is, but it looks like all these a values are 1. But since I don't really know, a is just a. Can't assume it's 1 because it has some pattern being 1. I don't really know. So because of that, a is just going to be a. So when I write this equation, it'll be y equals to a, and x plus 4, and then x subtract 2. Why is x plus 4? Basically, whatever the sign is in the intercept, as on the graph, is going to be the opposite sign when I place it in parentheses. Hence, if that's -4, this is +4. If that's +2, this is -2. It was the same in all the other ones too. If you notice, that was 5 on the graph, but in the intercept form, it's subtract 5. And here, it was 1 on the graph, but after I use it in the intercept form, it was subtract 1. So this is as far as I can go until I know what a is. and I have no way of finding out what A is with that information at the moment. Let's get another one. But technically, if I really wanted to, I could find that A value. For example, if I chose any other point for X and Y, I could figure out what A is on that graph. So technically, it looks like this is a point on that graph that I can easily find X and Y for. So I'm going to use this point. That point is 1, negative 1, 2, 3, 4, 5. So that coordinate is 1, negative 5. This is an X and Y value I can plug in to find A. So if that's true, I can replace Y with negative 5. A is still A. I can replace every X with 1. So it becomes 1 plus 4. And 1 take away 2. So now the only variable left is A. So if I saw this, it would be negative 5, and then A times 5 times negative 1. And that leads you to knowing that this is an 8, not a 9. It's going to be negative 5 equals to A times negative 5. And I know A has to be 1, because we're going to divide both sides by negative 5. You wind up having negative 5 over negative 5, which is 1, and that's equal to A. So coincidentally, A was 1. So technically, since I now know A is 1, by choosing another point on that graph to plug in for X and Y, I could just write a better equation. I could replace that A with a 1. So I do know the true equation for that graph. I've already checked it out, A is 1. So A for all these end up being 1. But looking at this graph, pause the video and see if you can find P and Q. So pause the video and give it a shot. See if you can find P and Q in the equation. Alright, hopefully pause it. Hopefully found that the first value for P or X was 0 and the second one was 5. So that equation would be Y equals to 1 X subtract 0, then X subtract 5 in factored form or intercept form. So truth be told, I really wouldn't write X subtract 0 after that line, so I'm going to call that X and X subtract 5. And the 1 is understood in front anyway. So that's the factor form for that equation. The second part of that equation says write in standard form. Now, if you want to write in standard form, I can tell you one, but there's another video I have already posted on writing in standard form. Given this equation, in order to write that in standard form, you simply FOIL together the two binomials. So it's going to be y, x times x, and then x times 3. So it's x squared, take away 3x. 1 times x and 1 times 3 gives you 1x, take away 3. So it's going to be x squared, take away 2x, take away 3. So that will be the equation in standard form. You just FOIL those together. And you want more practice than that, I got a video posted, probably the previous video in this list that explain how to rewrite any of these equations from this form to standard form. All right, that's all I have. Good luck.